so now let's talk about percent yield. So to understand percent yield, you need to know the theoretical yield and the experimental yield. So the theoretical yield is the amount of product you can theoretically get, and you can determine that through stoichiometry. The experimental yield is the amount of product you can actually physically isolate from the reaction. You get that from actually doing the experiment in real life. So the equation for it is pretty easy. It's just percent yield equals the experimental yield divided by the theoretical yield times 100%. So in real life, the percent yield is always going to be less than 100%, and there are 4 reasons for that. The first is you could have some unreacted reactants. So that means that you put in a whole bunch of reactants to start your reaction, but they don't all react. A little bit is left behind that doesn't actually participate in the reaction. The second reason is when you're trying to isolate your product, you actually lose it. So if you're isolating and purifying it, you're going to be mixing it, you're going to be precipitating it out, you're going to be dissolving it, you're bound to lose some. The third is your product could possibly decompose before you can isolate it all and measure it. If that's the case, then you won't actually be measuring your product, you'll be measuring the decomposed products. The fourth reason is the reactants that you started with, you go into the reaction thinking that they're pure, but they actually were impure. So instead of starting out with 100% of, say, glucose, you start out with 98% pure glucose. So let's take a look at an example of percent yield. So here I have the reaction between hypobromous acid and hydrobromic acid reacting to form water and bromine gas. So in the question you have 20 grams of hypobromous acid and excess hydrobromic acid. So that means hypobromous acid over here is going to be our limiting reagent. After doing the experiment, we isolate 17.3 grams of bromine. So to figure out the percent yield, first we need to figure out the theoretical yield. So the theoretical yield, like I said before, can be determined by stoichiometry. So first we need to know the moles of something. So the only information I gave you was 20 grams of hypobromous acid. So we can find the moles of hypobromous acid. So that's just, remember, the mass divided by the molar mass of hypobromous acid, which is 128.91 grams per mole. When you do the math, you get 0.155 moles of hypobromous acid. So to get the moles of bromine, you just need to multiply 0.155 moles of hypobromous acid by a conversion ratio. So we know that it's 1 to 1 ratio, so it's just multiply by 1, divide by 1, so essentially we did nothing. But we know that the moles of bromine must be the same as the moles of hypobromous acid, so 0.155. To get the mass of anything, given the moles, you can just multiply the number of moles by the molar mass. So we have 0.155 moles of bromine, and the molar mass of molecular bromine is 159.805. So after doing the math, we get 24.8 grams of bromine. So like I said before, the percent yield is the actual yield, so the yield that you get from experiment, divided by the theoretical yield, so the yield you get through stoichiometry. So in our case, I said that we had isolated in the actual experiment 17.3 grams of bromine. So that's 17.3 grams divided by the theoretical yield, which we just calculated through stoichiometry, which is 24.8. So that gives us a percent yield for the reaction of 69.8%.